Have you ever gazed at the night sky and wondered about the mysteries it holds? The cosmos, a boundless expanse of time and space, brimming with celestial bodies and phenomena, has long captivated the human imagination. The twinkling stars, the glowing moon, the radiant sun, they're all part of an intricate cosmic ballet that unfolds high above us. From ancient civilizations who worshipped celestial bodies as deities, to the spacefaring explorers of today, we humans have always been drawn to the heavens. They've inspired our myths, guided our voyages, and challenged our understanding of our place in the universe. This fascination, this yearning to understand the cosmos, is as old as humanity itself. Venturing into this cosmic ocean, we find our home, our solar system. This celestial neighborhood of ours is a minuscule part of the universe, and yet it's teeming with a complexity and diversity that leaves us in awe. It's a symphony of planets, moons, asteroids, and comets, all dancing to the tune of gravity around a central star, our sun. Yet despite centuries of gazing upwards, we've only just begun to unravel the secrets of the cosmos. With every passing day, we uncover a little more about the nature of our celestial neighborhood, its origins, its dynamics, and its future. From the fiery surface of the sun to the icy realms beyond Neptune, every corner of our solar system holds a story waiting to be told. The vastness of the cosmos may seem overwhelming, but remember, every grand journey begins with a single step. It's time for us to embark on an exploration of our solar system, an adventure that will take us from the heart of the sun to the edge of the cosmic wilderness. We'll journey past the rocky inner planets, through the asteroid belt, beyond the gas giants, and out into the icy depths of the Kuiper belt and the Oort cloud. We'll discover the unique characteristics that make each planet and celestial body in our solar system special. Join us as we journey through our cosmic neighborhood, our solar system. Imagine a sphere of hot plasma with internal convective motion that generates a magnetic field. That's our sun. Our sun, a star around 4.5 billion years old, is the heart of our solar system. It's a gigantic fiery sphere, over 100 times the diameter of Earth, and it's composed of hydrogen and helium, with trace amounts of other elements. In the core of the sun, a process called nuclear fusion occurs, where hydrogen atoms combine to form helium. This process releases an enormous amount of energy in the form of light and heat. This energy, this sunlight, takes about 8 minutes and 20 seconds to reach us, traveling across the 93 million miles that separate us from the sun. This energy is vital. It's what powers photosynthesis in plants, the process that produces oxygen for us to breathe and food for us to eat. It provides the warmth we need to survive on Earth. It drives our weather systems and our climate. In essence, this energy, this light and heat from the sun, is the lifeblood of our planet. But the sun's influence extends far beyond Earth. Its gravity keeps all the planets in their orbits, from the closest, Mercury, to the most distant, Neptune. It sends out a stream of particles, known as the solar wind, which shapes the tails of comets and creates the beautiful auroras we see at our planet's poles. The sun is also our most important source of energy. Every day, it pours out more energy onto Earth than humanity could use in a million years. Harnessing even a fraction of this energy through solar power could provide a clean, renewable source of power for the future. Yet, despite its importance, we often take the sun for granted, seeing it as just a bright light in the sky. But it's so much more than that. It's a star, a furnace, a powerhouse. It's the center of our solar system, the anchor that holds everything together. It's our life giver, our energy source, our light in the darkness. Without our sun, life as we know it would not exist. Nestled close to the sun, we find 4 rocky worlds known as the inner planets. First in line and closest to the sun, we have Mercury. It's a tiny, cratered world, not much bigger than Earth's moon. With a day that lasts over 58 Earth days and temperatures that can reach a sizzling 800 degrees Fahrenheit, it's a world of extremes. But don't let that fool you. At night, without an atmosphere to hold in the heat, temperatures can plummet to a frosty minus 290 degrees Fahrenheit. Talk about a place of contrasts. Next up is Venus, Earth's sultry sister planet. Despite being similar in size and composition to our home, Venus is anything but hospitable. With surface temperatures hot enough to melt lead and clouds of sulfuric acid, it's the hottest planet in the solar system. But its beauty can't be denied. When seen from Earth, Venus is one of the brightest objects in the night sky. Third from the sun, we find our home, Earth, the blue marble, the only place we know of that supports life. With its breathable atmosphere, liquid water, and moderate temperatures, Earth is a haven in the harshness of space. It's our oasis in the cosmic desert. Last of the inner planets is Mars, the red planet. Despite its nickname, Mars is more of a butterscotch color. It's home to the tallest volcano and the deepest, longest canyon in the solar system. And there's evidence of liquid water in its past. Could it have once harbored life? Or could it perhaps one day be a second home for humanity? From the scorching surface of Mercury to the red plains of Mars, the inner planets are a study in contrasts. Each one unique, each one a world unto itself, and all part of the grand tapestry of our solar system. Beyond Mars lies a vast cosmic junkyard, the asteroid belt. Imagine a region of space so cluttered with remnants of the solar system's formation that it's been likened to a cosmic junkyard. This is the asteroid belt, a donut-shaped ring of countless rocks, large and small, that orbits the Sun between the orbits of Mars and Jupiter. The asteroid belt is a fascinating place. It's not just a collection of rocks, but a treasure trove of information about the early solar system. It's home to millions of asteroids ranging in size from tiny pebbles to objects hundreds of kilometers across. Most of these asteroids are made of rock and metal, but some contain water, organic compounds, and precious metals. Now, you might be wondering how the asteroid belt came to be. Well, there are a few theories. One of the most popular suggests that the asteroid belt is the result of a planet that failed to form. In the early days of the solar system, a protoplanet might have been forming in this region. But the powerful gravitational pull of Jupiter prevented the material from coming together to form a planet. Instead, it remained a chaotic collection of rocks, forever orbiting the Sun. Another theory posits that there was once a planet in this region that was destroyed in a catastrophic event, leaving behind the debris we now know as the asteroid belt. Both of these theories, while different, underscore the dynamic and often chaotic nature of our early solar system. These asteroids, these remnants of a time long gone, continue to orbit the Sun, a testament to the formation and evolution of our solar system. They hold the keys to understanding our past and could potentially provide resources for our future. Despite its reputation as a cosmic junkyard, the asteroid belt is far from being just a pile of space debris. It's a region of immense scientific interest, filled with potential for exploration and discovery. The asteroid belt, a testament to the chaotic nature of our early solar system. Further out, we encounter the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune. Jupiter, the largest planet in our solar system, is a behemoth with a magnetic field so strong it's second only to the Sun. Its signature feature, the Great Red Spot, is a tempest larger than Earth that has been churning for centuries. Jupiter is also a celestial king, boasting a royal court of 67 known moons, including Ganymede, which is even larger than the planet Mercury. Then there's Saturn, the jewel of our solar system, encircled by a dazzling system of rings composed of billions of ice particles. Saturn's largest moon, Titan, has a thick atmosphere and liquid methane lakes, making it one of the most Earth-like places we've found. Beyond Saturn, we find Uranus, an ice giant with a unique tilt. Uranus spins on its side, possibly the result of a colossal cosmic collision. This sideways spin gives Uranus extreme seasons and a set of faint, thin rings. Its moon, Miranda, is one of the most bizarre worlds in the solar system, with a chaotic mix of canyons, cliffs, and craters. Lastly, we reach Neptune, the outermost giant. Despite its distance from the Sun, Neptune is a dynamic world with the fastest winds in the solar system. Its moon, Triton, spews nitrogen geysers into space from a surface that's frozen at -390 degrees Fahrenheit. These giant planets are not just colossal in size, but also in their impact. They've shaped the solar system, slinging comets inward, protecting the inner planets from excessive impacts, and even ejecting objects entirely out of the solar system. Each one is a world unto itself, with unique atmospheres, complex ring systems, and fascinating moons. The giant planets, each a world of wonder, add to the diversity of our solar system. Our journey doesn't end with Neptune. Farther out, we find the Kuiper Belt and the mysterious dwarf planet, Pluto. As we traverse the vast expanse of our solar system, we stumble upon the Kuiper Belt, a celestial region that lies beyond Neptune's orbit. This is a realm of ice and darkness, where countless small bodies, remnants from the solar system's formation, huddle together in the cold. It's like the asteroid belt's frosty cousin, only much, much bigger. The Kuiper Belt is home to a myriad of objects: icy comets, frozen rocks, and dwarf planets. They are the leftover building blocks, the remnants that never coalesced into full-fledged planets. These objects, often referred to as Kuiper Belt objects or KBOs, orbit the Sun at a distance that makes the light of our star appear as faint as the other distant stars in the sky. And then there's Pluto, the most famous resident of the Kuiper Belt. Once considered the 9th planet of our solar system, Pluto was reclassified as a dwarf planet in 2006. This decision sparked a debate that still rages on today. For some, Pluto's demotion was a necessary step in the evolution of astronomical classification. For others, it was a harsh blow to a beloved celestial body. Pluto, with its 5 known moons, is an intriguing world of ice and rock. Its heart-shaped glacier, known as Tombaugh Regio, is a testament to the complex geological activity that can occur even in these distant, frigid realms. This small world, with its eccentric orbit and tilted axis, challenges our understanding of what it means to be a planet. The Kuiper Belt, with its myriad of icy bodies, is a fascinating region to study. It offers us a glimpse into the early solar system, a frozen snapshot of the materials that built the planets. It's a place of mystery and intrigue, a frontier waiting to be explored. The Kuiper Belt, a realm of ice and darkness, marks the boundary of our solar system. Beyond the Kuiper Belt lies the farthest reaches of our solar system, the Oort cloud. This incredible region is believed to be a vast, spherical shell enveloping our solar system. And it's so far away that it's technically closer to the next star, Proxima Centauri, than it is to the Sun. The Oort cloud is named after the Dutch astronomer Jan Oort, who first proposed its existence back in the 1950s. But despite its theorized presence, we've never directly observed the Oort cloud. Instead, its existence is inferred from the behavior of certain comets that swing by our Sun on incredibly long elliptical orbits. These are known as long-period comets, and they're thought to originate from the Oort cloud. Their orbits can take them hundreds, thousands, or even millions of years to complete. Some, like the famous Halley's Comet, return within human lifetimes, while others, like the breathtaking comet Hale-Bopp, won't grace our skies again for another 2,000 years. But what is the Oort cloud made of? Well, it's believed to be filled with billions, perhaps even trillions of icy bodies left over from the formation of our solar system. These are frozen remnants of the primordial material that formed the Sun and planets, preserved in the deep freeze of space. Now let's talk about the edge of our solar system. It's a tricky concept because space doesn't have a clear-cut boundary like a country on a map. But in a sense, the outer boundary of the Oort cloud represents the gravitational limit of our Sun's influence. Beyond this point, the gravitational pull of other stars becomes more prominent. So as we contemplate the vastness of the Oort cloud and the edge of our solar system, we're also contemplating the incredible scale and complexity of the cosmos. The Oort cloud, a distant echo of our solar system's formation, stands as the final frontier in our cosmic neighborhood. Having journeyed from the Sun to the Oort cloud, what does our exploration of the solar system tell us about our place in the cosmos? As we traverse the vast expanse of our solar system, we are constantly reminded of our humble beginnings within this cosmic realm. Our understanding of the solar system is not just a testament to human curiosity and scientific pursuit, but it also holds a mirror to our existence, our place in the universe. Each celestial body, from the scorching surface of the Sun to the icy realms of the Oort cloud, is a chapter in the cosmic narrative that we are a part of. These chapters reveal fascinating stories of formation, evolution, and survival in the harshest of conditions, reflecting the tenacity of life itself. Understanding our solar system allows us to put things into perspective. For instance, the sheer size of the universe is a humbling reminder of our insignificance on a cosmic scale. Yet it also highlights our unique position. We dwell in a Goldilocks zone, a rare space where conditions are just right for life as we know it to exist. This understanding fuels our quest for discovering life beyond Earth. The knowledge we gain from our solar system also helps us seek answers to broader questions. What is the nature of the universe? How did it begin? How does it work? And perhaps the most profound of all, are we alone? These questions guide our exploration and push the boundaries of our understanding. Our solar system is a microcosm of the universe. By studying it, we learn about the fundamental processes that govern the cosmos. We understand how stars form and die, how planets evolve, and how elements essential for life are created. This understanding not only enriches our knowledge but also deepens our appreciation of the universe. As we continue to explore, we realize that our solar system is but a tiny speck in the grand tapestry of the universe. Yet it is our home, our origin, and our guidepost in the cosmos. It is here, in this tiny corner of the cosmos, that we have begun to understand the universe and our place within it.